I'm just going to kind of peruse through both of them at the same. Remember, the reason why I gave you guys the two separate types of packets was the fact that they're the same problems, just different numbers. So we've got two different sets of things to go back and look at and reference and whatnot. I know that I saw, James, you were looking up online, looking at the answer guides. Remember, the PDFs of the answers are on December 7th for the calendar day. That's where all of those are at. If worse comes to worse, these are the two original copies. I'll leave them out. If you want to just take a picture, it's fine, not a big deal. I haven't done any worked out keys on these things. I figured I was just going to kind of putz through most of it and work together with you anyway. So, excuse me. Now, when I was saying that with the final being multiple choice and the final being partially, what do you call it, free response, that means that if it is a multiple choice question, the answer is in front of you. Rather helpful. So if you know that, if you knew that, for example, you had to solve a system of equations via elimination, would you even waste your time doing that if it's multiple choice? No, what would you do? Plug and chug. Absolutely. Now, here's the other thing. If it's a system of equations, do you guys remember that fancy little thing that we did at the beginning of the semester about how do you solve systems of equations via the calculator? What is it? The 3 rows thing starts with an M and ends in an X. There's an 8. Yeah! So let's briefly discuss quick ways of remembering how to do things. For example, if by chance you had to solve a system of if by chance you had to solve a system of equations that you had to do by hand, write out the answers as an ordered pair, and you didn't have multiple choice, the easiest way to do that would be to use a matrix, because you've got a flipping calculator. Alpha Zoom. Remember that? Alpha and all the different shortcut keys are generally at the top. Those are going to be your best bet to go through them. And remember, the idea is that you have 2 equations, 2 variables. So what we're going to do is we're going to create a 2 by 2 matrix. So we have 2 rows and 2 columns. Again, I apologize. It takes a second or two for me to type this through on this calculator versus yours. Alpha Zoom. So I'm on ID number 1. I'm going to look at number 3. Okay? ID number 1, number 3. And now when you put these in here, you're looking at just your coefficients. What this is called is a coefficient matrix. -6, right arrow. -7, right arrow. -7, right arrow. -5. When you're solving a matrix for a system of equations, you do what we call that coefficient matrix. We put it to the -1 power. That means inverse. The -1 power is right above the x squared. You just hit the button. Then we have to create what's called a column matrix for the solutions. So we do another Alpha Zoom. And this time it's going to be 2 rows, 1 column. And remember, if it doesn't look the way you think it should, you just change it and you'll see how it goes. And I put my answers here. It's -6, -26. And make sure you use the negative button, not the minus. And if you do that correctly, your answer would be, as an ordered pair, 8, -6. Absolutely, good job. Thank you for not sending me with your pen. I appreciate that. Okay? Use the tools at your disposal to make your life easier. There were times and places for calculator usage. Finals, one heck of a time and a place for calculator usage. Okay? Systems of inequalities, shading. Okay, vaguely remember that? All right, good. I'm glad you don't have a clue. So I'm going to look at number 5. I'm going to stay on ID 1. So if you've done either one, I'm just because happens to be just for, sorry, I have no idea why I can't get rid of this sinus thing driving me up the wall. So I feel fine, I just can't breathe. That's not good. No, I'm okay without the inhaler, but I appreciate the worriness of my well-being. Yeah, right. I'm gonna call Lockhart. I should call him right now. No, because you offered me drugs. It's drugs.
It's steroids. Steroids are illegal.
I want to fall. You are.
Arnold Schwarzenegger.
Hans and Franz from Saturday Night Live. I am Hans and you are Franz. Listen to me now and hear me later. Trust me. Write this down. Write this down. Your job this weekend is that you have to watch 2 Hans and Franz videos. And you have to report back on Monday. All right, so when we do these, we go to our graphs. These are real quick, easy problems to worry about. You start your y-intercept, walk your slope, start at -3. When I connect those, is it a solid or a dotted line? I was seeing if you were paying attention. Good job. Don't give me that condescending tone there, Nora. That just means you're awake. Is it a solid or a dotted line between those? Why is it solid? Very good. All right. Test point. 0, 0. And why do we use 0, 0? Because it doesn't go through it. Good. So what's -2 times 0? 0. What's 0 minus 3? Is 0 bigger than -3? Yay! So you shade this way.
Would it work to just shade in the direction that you're out?
I would never follow that because of the negatives and stuff that throw around. Okay. And then the other one is you start at the +3. Solid again. Oops. Is 0 bigger than 3? Nope. So 0 is not bigger than 3, so it's false here, it's true here. So your overlap would be beyond that. Right? Yeah. Remember what happens here is that the graph is cut into what's called half planes. Half of the graph is true, half of the graph is false. We're shady individuals. We want to cover up the truth. And that's what it is.
It's a conspiracy.
Conspiracy. Yeah, if it doesn't go through 0, absolutely. Easiest way to do it. Okay. Discriminant. If one of the things that was really important that we learned about with quadratics, and obviously I know that we did a little bit more stuff in chapter 3. I'm going to come back to that on Monday with a couple extra problems with, remember when we did constraints? And they were like the word problems on crack, but it was just like, feasible region things. I've got an example of one I just didn't have on here. I'll go walk through with you guys on Monday. And it's very simple. It's just a matter of can you figure out if things lie within the region. It's not that you have to come up with word problems. There's no time for that on the final. Discriminant. When we're dealing with quadratic functions, we're dealing with functions that are in the form of y equals ax squared plus bx plus c. Does that vaguely ring a bell? Now, you have the thing called the quadratic formula. X equals -b plus or minus square root of b squared minus 4ac all over 2a. So you had that thing. But you also had the thing in there that was called the discriminant. What was the discriminant? Very good. So the discriminant is the b squared minus 4ab. What did that tell you? Yes. How many solutions and what kind? Very good, very good. So the discriminant told you how many solutions and of what kind. What you meant by what kind is what type. Real, imaginary. Okay. So if the discriminant was positive, how many solutions did you have? 2. Were they real or imaginary? Real. Very good. If it was positive, you had 2 real. If it was negative, very good, you had 2 imaginary. And the other version of it, if it was 0, you had 1 real. That meant it had multiplicity. This is when you had the quadratic formulas, if it changed direction on the y-axis, or excuse me, on the x-axis, that meant it had 1 0. And it had multiplicity of that value. Because it was a squared function, which means it has 2 zeros, but since it touches at one spot, it had multiplicity. We never said multiplicity until a couple of months later. We talked about polynomials. But I referenced that back to stuff that you knew. And your guys went, oh yeah. You had 1. Okay. And that's what happened. So if I'm looking at number 9, I look at number 9, it says negative 9x squared minus 6x minus 4 equals negative 3. And it says you find the discriminant of a quadratic equation that states the number and type of solutions. Well, what's the very first thing you have to do? Move that negative 3. Very good. Move the negative. You have, in order to do anything like this at all, you have to have one side equal to 0. Well, this is pretty simple. You just add 3. If you add 3 to negative 4, what do you get? Negative 1. I like how the fact that they threw a b value that's negative. What should you always do when you're working with the discriminant? No matter what. If it's negative, what should you just do? Right. Because no matter what you do, if you square negative 6, what are you going to get? If you square 6, what are you going to get? So no matter what this value is, just write down at 6. Don't screw up by putting the negative in there and squaring the negative, and all of a sudden you get negative 36 because you forgot to put parentheses. Remember that no matter what you do, if it's negative when you square it, it becomes positive. Just write down the positive number. Okay? Does that make sense? Shortcut your life. Not like as in for life, but make your life easier.
Shortcut your life.
Did that mean this come out really crazy like that? You're welcome. You can tell right now, hopefully, what's it going to be without even mathing in it? Excuse me. So you have 36 minus 30, or plus 36 minus 36, and you get 0. How many and of what type? One answer, and it's real. Yay, discriminant is your friend. You sound like Nora. Correct. Well, just because he can put stickers on us and they stick. We can. Completing the square. Number 11. What is the one rule that you have to have in order to complete the square? Yes, sir. Correct. Leading term coefficient has to be 1. Okay. No matter what. So right off the bat, You divide everything by 10. Uh, 45 over 10 is what? 9, excuse me, 9 halves. Okay. Now, when you start thinking about it in terms of multiple choice, if this is a multiple choice question and they're asking you what to do, it might be, what would it look like? What would the steps look like? If it was a solve an equation, I don't know if you would be able. If it says solve the equation, it's kind of silly to have you solve an equation and just say, hey, make sure you use this method, because when we did that, after we practiced a couple of times, you guys knew that there were certain times it was easier to do one method versus another. If I solved this equation to start with, 10x squared 20x plus 45, and I had to find my zeros, what am I going to do right away? Exactly. I'm going to use the quadratic formula right away, because why waste my time doing anything else? I didn't hear you. You got to be louder. You should sit up front and yell. But here's the thing. What happens if it asks you to show what it would look like? You know what I mean? What would your steps look like for using quadratic, using this? So it's the idea of process. First thing you do is move the C value. Put a blank in. Just like that. Remember that? What do you put in the blanks then? Remember that? Ooh, boy. Boy, Hannah, your voice changed and it got closer.
I'm sorry, you're using it until it's too late.
Remember what you're doing. You take half of B. It drops to the parentheses. You square it, and you add it to both sides. Does that vaguely ring a bell? So then this would equal negative 9 halves plus 2 over 2 would be negative 7 halves. And then from there you would square root and add and subtract 1. Half of B, square it, and add that value to both sides. Completing the square. If you remember, the practical use for that was when we dealt with some mechanic stuff, when we got into ellipses, finding out how to switch from one version, from one form to the other. That's where we used a lot. Right. From there, I'm sure we can solve that one out, right? Let's see. If I go to 13. I have 49x squared plus 4 is negative 35x. And it said solve by factoring. Okay? If this is multiple choice, what are you going to do? You're going to plug and chug. In all honesty, that's the idea here. If it's factoring, now, leading term coefficient of 49 kind of doesn't look very good. I'm not a big fan of this. That doesn't look all that fun. But do you happen to have this rectangular shaped object with a handful of buttons on it?
What object?
Maybe that it's yellow.
A school bus?
No, obviously. Obviously, when we dealt with this stuff back in quadratics, I didn't really show you guys all the big, giant capabilities of the calculator, because I didn't want you to rely on it. There's a time and a place. Finals is the time and the place. What are your y equals? Um, 49x squared, I believe. Plus 35x, was that right? Thank you. And then plus 4? Try to remember what it was. Okay. Now, I don't want to factor that, but we all know that synthetic division is also a means of factoring, isn't it? So if by chance I find a clean 0 by going to my table, Doesn't look like I have any clean zeros though. Okay. Go to your graph then. Oh, let me change my graph, my window. If your window's all sorts of messed up, just do the regular 10 by 10, the negative 10 by 10. Remember how to change that? Window, excuse me, negative 10, 10, negative 10, 10. Okay. It appears as though I crossed the x-axis somewhere around between 0 and negative 1. So, why not do a calculate? Second, calculate. 0. Go to the left of it. Oops. Go to the right of it. Oh, that's a really crummy 0. That's not going to help us very much, is it? Okay. So in this case, we might actually have to do some work. We'll get over it. In this one here, double 98. Oh, sorry. Double 49, you get 98. Double 98, you get 196. Okay. Now, if it's 196, and to add to 35, that does not look like a lot of fun. But if you look at the two numbers you started with, 49 and 4, why not try 6? We know 5's not going to work. Does 6 go into 196? 7? What's 7? Even though the numbers look awful, notice that we're just kind of guessing right around where the two multiplied out. 28, I originally thought, well, maybe 6, because it's close. And I just tried 7. I'm just fishing at this point. Okay. Now, if you go the rest of the way here, let's see, 49x squared, 7x, 28x, and 4. It's not terrible. Excuse me, 7 here. Take out 4. And if you solve it through, then you have 7x plus 1 and 7x plus 4. Negative 1 7th and negative 4 7th. Yes, sir. What do you mean by looking at it? Instead of doing what though? You did the same thing. You were just thinking you were doing this part in your head. You did the same thing. All right. You were doing the same stuff. Okay. All right. Now again, if this is multiple choice, would you have even wasted your time? No. But if it's multiple choice, you have fractions with negatives. You've got to make sure you put things in parentheses. Okay. Remember how to create a fraction bar in your calculator? How? Alpha y equals. Alpha y equals creates that. Wait. Well, if you were to plug every single answer into the calculator, it would take forever. That's why if you know how to get far enough, if you know just enough to be dangerous, you'll be okay. Why wouldn't you? Oh, if it's, well, here's the thing. Let's say you got to this, and that just looks awful. And if you're quick with typing buttons in the calculator, try to be, look, I would do that if it's quick enough. From here, if it was multiple choice, let's say you had I would just go, what was it, 7? I would type in 7 parentheses alpha y equals. Let's say I would just substitute in the ordered pairs they're giving you, or the 2 different answers, and I'm just substituting in the answers even equals 0. That's what I'm doing. Excuse me. Factor this pretty quick. Do I have to walk through taking square roots? Do I have to walk through solving quadratic formulas? No. But one of the things I want to make sure we hit here is the graphing portions. Identifying parts of quadratics. Axis of symmetry, things like that. So if I'm going to go back down to number 19. It says y equals x minus 9, x minus 1. And it wants to identify everything. So what we do here is this, if you recall, is intercept form. It's telling you where your zeros are going to be located. Your zeros are located at the zeros of the terms. Well, my terms are x minus 1, x minus 9. So my zeros will be at 1 and 9. Okay. Will this one open up like a cup or down like a frown? Why? First thing is positive. Very good. The value in front of the first parenthesis is positive because there's nothing there. Right? So we know it's going to be up like a cup. Now, the axis of symmetry is always located at the halfway point of a 0, no matter what. So what is 1 plus 9? 10. What's half of 10? 5. So that means your axis of symmetry is at x equals 5. 2, 3, 4, 5. Which therefore means that your vertex always lies upon the axis of symmetry. So what do I substitute in for x now to find my vertex? My y value? 5, exactly. So you go to your calculator, you put in parentheses 5 minus 9, close parentheses, open another one, 5 minus 1. Negative 16, I believe. Your vertex then is at 5 comma negative 16. Your vertex always lies upon the axis of symmetry. Your vertex, if it's up like a cup, is that a maximum or a minimum? Minimum. It's the low spot. It's the low point. Okay. If it was down like a frown, it would be a maximum. Yes, ma'am. You shouldn't have to know how to. Graphing is kind of irrelevant at this point because I'm going to let you use the calculator. But you have to know how to find the parts. Ask where's the axis of symmetry? Where's the vertex? Things like that. Right? How'd you find the y-intercept? What's that? Is it y? I didn't hear what you said. My ears are really clogged. I'm really sorry. Y-intercept?
Just put in 0 for y.
Not for y. For x. Very good. If I ask you where's the y-intercept, you just remember your y-intercept is when x equals 0. What's 0 minus 9? What's 0 minus 1? What's negative 9 times negative 1? And that's where you would go from there. Now, on the other hand, if you go through on number 20, excuse me. This is almost in that vertex form. Remember we did vertex form? Remember that? Where H and K were your, for the vertex. A value told you what? Direction again. Yeah, exactly. So in order to get it into that form, all I have to do is move the 7. So if y equals the quantity x plus 4, quantity squared, minus 7. Well, where's your vertex? -4, is it 7 or -7? -7, good. Your vertex is at -4, -7. Where's your axis of symmetry? Excellent. Your axis of symmetry is always the x-coordinate of your vertex. Is that a vertex? Is that a maximum or a minimum? Is it a maximum or a minimum? It's minimum because it's up like a cup because the a value here is positive. Okay. Now let's say you completely forgot all of that. You went, oh crap, I got to go back and remember all that. Is there some sort of device that happens to be yellow with multiple buttons on your desk or somewhere close that you could probably throw this into the y equals because, oh, I don't know, there's a y equals to figure all that out? Yes. Let me show you. Again, you do parentheses x plus 4, plus 4, quantity squared. Oops. Minus 7? Gee, I wonder what I could press to find. Calculate. What am I looking for?
0.
Not a 0. 0 is the word across the x-axis. I'm looking for the minimum. Very good. I'm looking for that minimum because that's the low point. It'll tell me where it is. Waiting. No, I'm just saying that if you let's say you forgot how to do all that, but if you can get it to the calculator, you can find it. It's awesome. Just make a cartoon. Da, da, da. Calculator man. What? I think it'd be great. Dun, dun, dun. Well, that's Captain Underpants when he does that, right? Dun, dun, dun. We need a different pulse. We need a different sound. Dun, 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 dun. No, 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 no. Yeah, I'm Calculator Man. No, 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 no. And I keep saying to herself, when does this start? I asked that you guys grab the quadratic word problem things. I don't know if you remember that. Now, can I say this real quick? When we did quadratic word problems back in the day, a lot of this stuff stemmed from throwing it into the calculator to understand what it was looking for. Was it looking for a maximum height? Was it looking for how long it was in the air? Like the cannon shot. Remember what it says versus height versus time. Something along those lines. We also did the problems where we had the sales. So sales of one thing, at a certain price, you increase it, it does something else, you lose sales, that kind of stuff. For example, which one was it? There was a good one in here about shoes. Yeah, yeah. It's on the very first page there. It talks about shoes. I've always liked this as a very generic one. It says you sell 200 pairs of shoes each month at $60 a pair. 200 pairs of shoes at $60 a pair. Okay. For each $1 increase in price, 2 fewer pairs of shoes are sold. So if this is my price and this is my sales units, like how many I'm selling, for every increase, it said $1, I believe. Every increase of $1, I sell 2 fewer. Now, remember what the X represented here. X represented the number of times you increase by $1. X represented then if it was increasing one time, you increased it by $1, which means you decreased it by 2 sales. If you increased it 4 times, you increased it by $4, which means you decreased it by 4 times 2, which was 8 sales. That's what all that meant. That's what the X value represented. Now, if it asks you to find what is your maximum profit, that means you can figure out what's the biggest Y value you can get. If it asks you what is the sales price, you figure out what the greatest price would be, and you would substitute that X value into here. If it figured how many sales you would have, you put the X value into here. So let's go through the easy way of doing this. One of ways is to throw it into the calculator and search for it via the window. Takes a little bit more time, but also remember that this is in intercept form. Okay? This is in intercept form, which means you can get zeros. If I set 200 minus 2x equal to 0, I would get 2x equals 200. You okay with that? Which means x is 100. I have a 0 at 100. If I set 60 plus 1x equal to 0, I get negative 60 for a 0. Are we okay with that? What has to occur at the halfway point of negative 60 and 100? The axis of symmetry. What's negative 60 plus 100? 40. What's half of 40? 20. So the axis of symmetry is at 20, which means somewhere along there, the maximum or the minimum is going to occur. Is this going to be a maximum or a minimum? It's going to be a maximum because the x squared is going to be negative. If you FOILed that out, your x squared would be negative, so it would be down like a frown. So if I throw in 20 then into my calculator to figure out what my x value is, we'll get 200 minus 2 times 20. And then it was 60 plus 20. So it'll be 160 times 80, I believe. Does that sound right? I'm trying to do this off the top of my head here without moving this around. I guess I could just do this. Yeah, I did it right. So that means my y value would have been 12,800. This would have been my maximum. That meant that 20 represented the number of times you would increase by $1. What would be your maximum selling price? $80. The maximum sales figures are you would get. The maximum money would be 12,800. The number of pairs of shoes you would sell then would have been 200 minus 40, 160. That's what the x value represented. Okay. I know that we're going to run out of time here today. Try and get through as much of the polynomial junk and the conic stuff for next week, for next Monday. We're gonna go through as much. I'm not so polynomials. I know you guys are pretty decent with. It's just a matter of remembering how to do long division, synthetic division. What do all those things represent? We'll talk about quick things of conics and going back about how to figure out A, B's, and C's. That's about as complicated as we can get with some of those things. How do you identify vertices, something like that. We'll go do that on Monday, and then Tuesday we'll bum rush as fast as possible and have a good time come Wednesday. Hey, dance up a storm later today. I hope you guys do well.